Hello, and welcome back to this random capable FX stuff. Today we have this Atwater Kent Model 20 Compact. It's not in great shape. Let's see, most of the finish has gone off the top and on the sides as well. So cosmetically it's not in good shape. You can see some of looks like the paint's coming off the front, it's getting a bit rusty. The lid is not even attached. See, two screws there for that hinge, but this hinge is completely broken off the back of the board. You can see that it broke off where the hinge should be, so it's going to be interesting to fix. You can see the label there. But it does have all the tubes, which is one of the reasons why I got it, because tracking down these old tubes, like this uses 5. Originally took UV 201As, but these are all UX 201As. These tubes can be, like, if you need one, you can probably get it, but if you need all 5, they're a bit expensive. So we have all the tubes, so it should be good there. Hopefully these are all good. I did not check them yet, but hopefully these will be good, or at least most of them will be, and maybe we might need 1 or 2. Hopefully it won't be that bad. Anyway, so this is a independently tuned radio, so each stage is tuned separately. So it's kind of fun and annoying at the same time to tune these. I mean, fun in a sarcastic way, because you have to get all 3 dials lined up to the same frequency in order to get the signal through the radio. So this is a antenna intensity switch here, so this just determines how much of the antenna couples into the radio. Alright, these are 2 separate filament intensity switches, and this is the power switch down here, just pulls out for on and pushes in for off, I believe. So let's get this taken out of the case. These old style radios, everything is attached to the front panel, so you just take the screws out and the front panel should slide out with the rest of the radio attached to it. This is before they switched over to a regular chassis type design, and they just mounted everything hanging off the front panel. And also, I think this is from either 24 or 25. The original Model 20 came out in 24. I'm not sure when this compact one came out. So let's take all these screws out and we'll see if we can slide this out. Alright, so I had to take the tubes out to get it out of the cabinet. The tops of the tubes were hitting the front piece across the front of the cabinet, so I took those out. But it is out now. You can see there are 3 separate tuning condensers, or capacitors. This would be our audio interstage transformer for detector to audio amp, and a second audio interstage transformer from audio amp to output tube. These did not use an output transformer or choke of any kind, and just connect the speaker in series between the B plus and the plate of the output tube. And these also didn't use any special output tubes. All the tubes in here are the same. They're all, originally they would have been UV 201As, but the ones that were in here are UX 201As. I've only ever come across one radio that came with a UV 201A in it. Most of the time they're all UX 201As. They're all of the globe kind. And if you ever wondered why these 4-pin tubes have a pin on the base there, it's because they're designed to work in place of the older UV tubes. So if you look at the socket, you can see there's a cutout in it, and if you look over, the cutout actually goes over. So you line up the pin with that cutout, drop the tube in, and you just push it down and rotate it, and that locks it in. The UV tube, so you see this is an NX 201A because it's a national tube. If it was an RCA, it would be a UX 201A, and if it was a Cunningham, it would be a CX 201A. The very first tube that RCA put on the market was a UV, there were 2 of them. There was a UV 200 and a UV 201. Now the difference between the UX and the UV is that the UV has long pins, and 2 of them are fatter than the others. You can see the top 2 are fatter than the bottom 2. Those are the filament pins. The original UV tubes had a much longer base and much shorter pins that were not keyed. You can see that they're just 4 flat plates down in the bottom of the socket. So when you push the tube in, it just pushes those pins against those 4 plates, and then this pin here does the keying. And when I switched over to the UV style, and they went to regular tube sockets where they're keyed based on the size of the pins. So I think around 25 or 26 was when they switched over to the UX type tubes. Most stuff before that was the UV type tubes. So anyway, that's why all the 4-pin tubes have a little pin on them. You can check pretty much anything like 71, even later tubes like type 80s, type 71s all have that pin on them for use with the old UV sockets. So anyway, we can do a little overview here. Put the tube to the side. You can see that originally these tube sockets were brass. These ones are looking pretty nasty here. They might clean up. I definitely want to check continuity of these two transformers because usually old iron core coils like this have a tendency to go open. So I want to verify those. If these are open, I'll probably just use a RC bypass for these. And there's really no sense in trying to source replacements here because you basically have to buy another radio of this kind and hope that those transformers will be good. So if these are open, we'll just use a RC combination to bypass these and couple that way. Let's move this forward. So you can see this is probably going to be the antenna input coil. You can see down in the bottom there's a wire wound resistor. Most of the resistors and stuff this old are wire wound. Carbon resistors they had them, but I think they were more expensive and harder to make than just wrapping some wire around there. So most of the resistors are wire wound in this stuff, and then the higher value ones like grid leap, which is like 1 mega ohm, those will be carbon resistors, but most of them are wire wound. You have another one down there, which I'm not sure if you can tell, but it doesn't look so hot. You can see a lot of the strands are all over the place, so there's probably multiple breaks in that one, so we might have to end up replacing that. On the back of this one, you have looks like a capacitor. And if you flip this up some more, you can take a look at the bottom there and see all the bottom of the tube sockets. Come over here. This is going to be the grid leak resistor most likely. A lot of times it's a socket. I'm kind of surprised this one is soldered directly in. But these old style carbon grid leak resistors are usually pretty interesting. This is one of the more boring ones, but sometimes they'll be like a glass tube with just like a single strip down the middle of the glass tube, almost looks like a fuse, and they'll be socketed, but this one is pretty boring and it's soldered in, so this is not one of the more interesting ones. I got another capacitor here, looks like. Got some tape. Not quite sure that's about. So yeah, this is our battery supply wire. This is going to have to get some work, obviously. A lot of bare wire there. So I think this one has an A battery, a B battery, and a C battery. And I think all the C battery does is provide grid bias for the output tube. Usually the B batteries can be anywhere from maybe 45 to 135 volts. Usually a bit lower on this older stuff. I have a Freed Eastman NR5 from 1923 that has 90 volt B plus and then a 45 detector battery. So this one's probably somewhere in there. I'll have to check out the exact specifications. For these are 5 volt tubes, the UX201As, but they take a 6 volt battery and then there's a variable resistor on the front, one of those knobs, to adjust the filament voltage down to the proper 5 volts. This usually also uses a volume control too. If your radio is too loud, you just turn down the filament voltage, which reduces the conduction in the tubes and reduces the volume. Then the C battery is going to be probably around 4.5 volts, usually what those are. So I think what I'm going to do is check out this resistor and this resistor, and I'm sure this one's going to be bad. You can feel the coils are loose on there, so there's guaranteed to be a break in that. And I'll check out the continuity of these two transformers, and I'll probably also check out the continuity of these two rheostats. These are going to be the filament adjustment. I'll have to clean up these contacts here. These are incredibly dirty, so I'm sure these are not making a good connection. And I'll probably clean up this power switch too. I'm sure this is not going to be working properly. So let me do all that checking out, and we'll see where we're after that. Okay, so I don't know exactly what I showed in the last section of this video, but I've done quite a bit of stuff here. I went over in the last section that how to replace one of the resistors. I also found that one of the tube filaments was open, so I had to order a new tube. So all the tubes should be good in there now. I've got all my batteries set up to power this up. I cleaned up the power switch and this switch, so that should be good. Got my speaker hooked up, so I think we're ready to do a power up here. Oh, also I changed the one paper capacitor. When I was hooking the batteries up, I did a whole bunch of voltage checks to make sure everything was hooked up properly. And I found that with the radio switched off, there was some leakage coming through the capacitor on the middle B plus line. So I changed out that capacitor because I was getting a little bit leaky. So I put a piece of tape here to indicate that's the part where I shouldn't turn this knob past. These are 5-volt tubes. So when this control is set to where this tape is, that's 5 volts, so I don't want to go past that and roast the filaments. We'll turn this down for initial startup. So let's turn it on and see what happens. See, the tubes are glowing. Sure, how are you going to be able to see it there? There, you can see it in there. So, I don't hear anything. Just tweaking. Don't hear anything at all. B plus is at 88.5, so that should be fine. If my speaker is not working properly. Let me check the voltage right across the speaker terminals. Maybe there's a bad connection there or something. So voltage was like, let's see what, I can't read it that way, so let's see what it is here. Volt. Oh, that should be okay. Why no sound is coming out? Let's move that off to the side. Getting absolutely nothing out of the speaker. Let's turn these up a little bit more. Oh, so when I do this, there's a crackle. Ah, that tube wasn't lighting up. Okay, now it's lighting up. I see after I roll it a little bit. I do have an antenna hooked up here. Not sure if this. So all these tubes are lighting up. This one I can't really tell because the getter's concentrated on the top. I'm going to try tuning something here. Now usually the way that you tune these is you work with these two and do a sweep on that one. So we'll tune. I don't really hear any static either, so. Disconnected itself again. going to be a tedious process because there's no guarantee that these two are aligned either, so sometimes it can be quite a challenge. Of course, I have no idea what setting this is on either. Two is also being difficult. I have to play with this for a little bit to see if I can get anything. So I'm kind of getting somewhere. If I touch the antenna to the second stage, so I am, stupid meter, I am able to get something.
And it's an unbeatable combination that gives you this cardiovascular system benefits to your brain, performance,
Pretty wide
and
tuning
aerobic capacity. It supports normal enzymatic activity throughout the body. It's just an amazing combination, and that's why we call it the advantage. Dr. Pressman, I love the fact that
But if I go back to the first stage, it's absolutely nothing. It doesn't matter where I poke this. If I poke it in here. No. So there's something up with this first stage not carbuncling through. I can see that the tube is glowing, but something else may not be making contact. So I'm going to see if I can investigate that and what the deal is there. This is the antenna coil here, so it should be getting to the grid of this tube. So I'm going to take a look at the schematic and see what all should be connected where exactly, because I'm not quite sure what the contact is here. Touching.
By a group of genes called sirtuin.
I assume that would be in the plate circuit, but I would like to double check. Actually, that should be in the grid circuit, I think, of this tube. So, yeah, let me just double check everything here. Okay, so I think I might finally be getting somewhere.
This is a powerful idea, Dennis, and this radio station is a place where powerful ideas and principles thrive.
This is the RF filaments. This is the output amplifier AF filaments. Doesn't have as much effect as this one. So as you can see, these are quite out of alignment. This one's at, what is it, like 17? This one's at 40, and this one's at like 12. See, that's where that one peaks. That's where that one peaks. That's where that one peaks. So I think the main issue that I was having was in the tuning capacitor there. You can't really see. There's a bit of rust on the central shaft all the way down, like right in there, and that looks like that's where it makes the ground connection. So I think that that there was a bit of resistance there in making the ground connection. So I sprayed some contact cleaner down in there and spun the controller around a bunch of times, and it seemed to have the effect of finally waking up this first input stage, because I got the antenna hooked up to there now. I don't have it hooked up to the antenna terminals yet. I have to clean those, I think. I think there's some corrosion and stuff on those, so that's not going to make good contact. But I am injecting into the grid circuit of this tube, the top of the tuning capacitor. So the signal is now making it through all the stages, which was not happening before. Also, my grid resistor seems to have gone out. I changed that. There's supposed to be like a 2 to 4 megohm. I put a 3 megohm in there, or 3.3 megohm. That stopped working. And also the primary of the second output transformer, the one that was a little bit questionable at the beginning. I was having I don't know if I showed that on video or not, but when I was initially checking this transformer, I had a bit of a time getting an accurate reading with it. I did finally get a good reading, but now that's gone completely open. So I just used a RC bypass. I can show you that later. Okay, so quite a bit has happened. I think last time I had the camera on, I did quite a bit of stuff off camera. I'll explain that in a minute, but so this is now with the antenna connected to the antenna terminal. Instead of injecting it into the second stage, now it's actually going into the antenna terminal and going through all the stages and coming out the speaker. This sets different taps on the antenna coil. So this is with most of the antenna coil engaged, and this is with one section cut out, and this is with almost none of the antenna coil engaged. So basically all that does is increases or reduces the coupling between the antenna and the first stage. So here there is only a few coils carrying the antenna signal coupling into the first stage, and here there's some more, and this is with all of the antenna coils coupling in. See if we can get some other stations here. It's not always the easiest, we'll turn this up a little bit. Let me turn the camera off and see if I can tune something else in. It's probably going to take some time. Let me turn the camera off so I can get something else tuned in. I got a pretty weak station here. Let me see if I can turn this up a little bit.
Here with us some of the headlines, the science behind resveratrol. I know it's from red wine. French love it, but why is it on your short list? Well, resveratrol is one of those remarkable compounds that...
This is the adjustment for the two RF tubes, and this is the adjustment for the detector and two audio tubes. So we got one here at 1540 19. I think there was another one down here around 730 or so. That kind of sounds like the same one. So I only got two so far. Could be because I don't have a ground connection on here, I just have the antenna. And it's not a super long antenna, so that could be part of it. Also, my batteries might be a little bit weak too, so probably going to play around with this a little bit more. But before I do that, let me explain what exactly happened here. So, I think I mentioned before that I was contacting the antenna to that brass screw down there, which is the grid connection. Well, it's on the other side of a resistor to the grid of this tube, which is the second RF tube. And then this over here is the antenna, this connection that I've cleaned up right here. This is the ground. So when I tried injecting to that brass screw, which is the grid for this tube, nothing was getting through. So I think what happened was, I'm not sure you can see, but there's some rust on the center of the tuning capacitor down there. I think that rust was preventing a good contact are causing a little bit of resistance in the contact from the center blades of the capacitor to ground. And if there's no connection there, then this is not going to resonate properly. So I sprayed some contact cleaner in there, worked it back and forth a little bit, and that seemed to activate this first stage. And then it cleaned up the antenna connection so I could connect the antenna successfully there. And that seems to have worked. So yeah, getting at least 2 stations. The weakness, again, could be one of many things. Could be that these old tubes are weak. I don't know how many hours they have on them. Could be that my batteries are a little bit questionable. None of these batteries are fresh batteries, so I know for a fact that the B plus batteries are dropping a little bit. So I didn't check the voltage on the A batteries, but it could be part of it. Yeah, another thing could be the ground connection. I only have the antenna. I don't have anything hooked up to the ground, so the antenna is not working against the ground like it's designed to. So things that can be played around with there. Other things that I should mention. Let's flip this up so you can get a look at the bottom here. So this is the capacitor I placed. There was actually a cylinder all the way. So as you can see it now, all the way up in there behind that tube, there's a little blobby thing, and that's the original capacitor. I can't really get it out of there, so it's just going to stay there. That was leaky, so I placed it with this. That's just a paper cap on the B plus line for filtering, RF filtering, because there's no AC hum in this one because it's battery powered. But so I replaced that because the other old one was leaky. Also, the one filament, or not filament, the one AF transformer. That's what it is. It's the AF transformer here. That went open. The primary went open, so I just bypassed that with an RC combination. You can see here, I got a resistor going from the high B plus. This resistor right here. This is the old connection for that transformer. I just taped it off so it didn't bother anything. Right here is where the my pointer. Right here is where the 90 volt B plus comes in to drive the 2 output tubes, or 2 AF tubes rather. So I just took a resistor from there to the plate of that first AF tube, and then I have a capacitor going from that plate to the grid of the second AF tube, or output tube, whatever you want to call it. It's not really an output tube per se, but it's acting like one, kind of. Anyway, so that is, this is providing the plate resistance, and then this is just coupling the signal over to the grid, which are the 2 functions that the transformer is doing. So the transformer winding would be the plate resistance, and then the magnetic coupling between the 2 coils would be the coupling that this capacitor is now performing. So as you can see, that worked out. We are getting audio out now. I don't know what caused it to go open. I don't remember if I mentioned this or not, but when I was initially reading it, it was hard for me to get a good reading on it. So I don't know whether it was like flaky and then suddenly made contact and then now stopped making contact, or what exactly happened there. But this should be a permanent fix, so I don't have to worry about that anymore. If the other one goes open, the other transformer, I can always do the same thing, just bypass it here. If the secondary winding goes open, that would be the grid resistance equivalent. You can just take a resistor from the grid. In this case, you'd be going to the C minus, I think, actually, is this, because it's a negative grid bias. So just take a high resistance value from there to the C minus connection, and that would substitute the secondary winding if that happened to go open. Found this trick online one time. The recommended value they had was 22K, so that's what I used, and it seems to work fine. The original transformer resistance would have been less than that. I think it was around like 2K, but that pure resistance doesn't account for the impedance, so I have no idea what the impedance of that winding would be, but it would be higher than the 2K because it's an iron core transformer. So the 22K seems to work out. I mean, if you wanted to, you could play around with different values there and see which one gave the best performance, but I'm going to stick with that. That works well enough for me. So, yeah, that's going to be about it for this video. The radio is working now. It's a little bit weak. I might try ordering some more tubes and playing around with some different stuff, getting new batteries, or maybe making a battery eliminator. But I'm going to split the video here because there already has to be a part 2 for the cabinet repair. So, radio is working now. Part 2, maybe we'll play around with some performance improvements, see if we can get it working a little bit better, but you can't expect a huge amount of performance out of these. These tubes don't have a particularly high gain. They're, first generation. These tubes are actually the 201 tubes. Basically, one of the first tubes marketed by RCA. The initial tubes that RCA released were the UV200 and UV201, and the 200 is just a gas-filled detector tube, and the 201 is basically what these are, a complete vacuum, or they call it a hard vacuum triode. And the A on the end of these ones just signifies that they changed the filament from pure tungsten to thoriated tungsten, and that's why these ones have that bright orange glow, because of the thoriated tungsten. So they don't have any oxide on the filaments. It's just a thoriated tungsten wire. And the older ones, the 200 with the pure tungsten, those ones glow bright white. I don't actually have any of those, so I haven't actually seen them myself, but that's what I've heard about them. And those old ones, the older ones, the 200, not the A, but the original 200 with the tungsten filament, each filament took about 1 amp, and then when they switched to the thoriated tungsten, each filament dropped down to 1/4 of an amp. So, it's a significant draw. You've got 5 tubes here, so that's 1.5 amps just for filament current. But if these had been the original 201s, you would have 5 amps for filament current. So definitely a significant battery drain there, and that's why they switched over to the thoriated tungsten. So, yeah, that's what I was saying. So these basically are the original triode tubes released by RCA. The only difference is the filament composition, and I don't think that would really have any effect on the tube performance other than it doesn't drain your batteries instantly. That's one thing you have to be careful about. These rheostats would be tuned for whatever tube the radio is expecting. So for 201A tubes, these rheostats were designed in mind that the current's going to be significantly less than 200A. So if you ever get like a radio that's designed for 200A, the resistance of these rheostats is going to be significantly less than a radio designed for. If you ever get a radio that's designed for 201 tubes without the A, the resistance of these rheostats is going to be significantly less because there's going to be much more current flowing through them. So you need a much less resistance to drop the voltage to get the right voltage for the tubes. So if you put 201A tubes in there, you have to be careful. The rheostats might not have enough resistance to drop the filament voltage appropriately. And those radios were only sold for a few years. I think the 201As came out in like 22 or 23, so just something to keep in mind if you ever come across that. Anyway, I think that's going to be about it for now. Like I said, this radio is functional, could be improved, so we'll take a look at that maybe in part 2. But I think this video is long enough, so if you enjoyed this video, and thank you for watching.